What's going on, everybody? Welcome back to my YouTube channel. Well, we have this question on the board which says find the value of the square root of 35 plus the square root of 45 plus the square root of 49 plus the square root of 63 all over the square root of 9 plus the square root of 5 plus the square root of 28. Well, our first step towards solving this question would be for us to simplify each of the sorts. That means the square root of 35 can be written as the square root of 7 times 5 plus the square root of 49 this is 45 rather. The square root of 45 can be written as 9 times 5 plus the square root of 49 can be written as the square root of 7 times 7 plus the square root of 63 can be written as the square root of 9 times 7 all over the denominator. We have the square root of 9 plus the square root of 5 plus, if you notice that I have 7, 5 and 9, so I'm going to be maintaining that. So the square root of 28 is the square root of 7 times 4. That's it. So now we are still going to simplify further. And how do we do that? Simply by separating the roots. So for this square root of 7 times 5, we can go ahead and write it as the square root of 7 times the square root of 5. We're going to be doing the same thing to the others, plus the square root of 9 times the square root of 5 plus square root of 7 times the square root of 7 plus the square root of 9 times the square root of 7. So all over the denominator, we have the square root of 9 plus the square root of 5 plus the square root of 7 times the square root of 4. Now, looking at the numerator, you notice that the square root of 5 is common here. And because of that, we can go ahead and factor that out. So the square root of 5. And what do I have? I have the square root of 7 plus the square root of 9. So the square root of 7 plus the square root of 9. Cool. Plus, now on this other side, I have the square root of 7 common. So I can go ahead and factor that out. So leaving behind the square root of 7 plus the square root of 9. That's it. So all over the denominator can be the square root of 9 plus the square root of 5 plus, now notice that the square root of 4 is 2. So 2 times the square root of 7, I have 2 root 7. And also notice that from the numerator, this is common. Square root of 7 plus square root of 9 is common, which can be factored out. So square root of 7 plus the square root of 9. So factorizing that out. Now this divided by this, I have the square root of 5 plus this divided by this, I have the square root of 7. So I've been able to factorize the numerator. What about the denominator? In the denominator, remember what I said? I said we are writing in terms of the square root of 7, square root of 9, and the square root of 5. So I can go ahead and simplify this further by writing it as the square root of 9 plus the square root of 5 plus, by writing it as 2 root 7 means the square root of 7 plus the square root of 7. So adding this up gives 2 root 7. So I am in terms of 7, 9, and 5. So let's go ahead and group the denominator. But I'm going to be doing something here. I'll be writing the square root of 9 first before the square root of 7. It's still the same thing. So we have the square root of 9 plus the square root of 7 times the same thing I'll do here. I'll write the square root of 7 before writing the square root of 5. So the square root of 7 plus the square root of 5. Remember, it is still the same thing. All over. For the denominator, like I said, I'm going to be grouping this. Grouping in a sense that I'll be grouping the square root of 9 plus the square root of 7. So let's do that here. Square root of 9 plus the square root of 7. I'm going to be grouping that. Square root of 9 plus the square root of 7 together plus, and then I'll group the square root of 7 plus the square root of 5. So I'm going to be taking this square root of 7 plus the square root of 5. So square root of 7 plus the square root of 5. So you can see that I have my question in terms of the square root of 9 plus the square root of 7 and the square root of 7 plus the square root of 5. So let's continue. So we can therefore say that let A be equal to this first one, which is the square root of 9 plus the square root of 7, and we can say let B be equal to the second one, which is the square root of 7 plus the square root of 5. So that means this expression can be written as A times B, which is what I have in the numerator, all over A plus B, which is what I have in the denominator. So we can say let this be equal to x. Our next step will be for us to take the inverse of both sides. The inverse of the left-hand side means we switch the positions of the numerator and the denominator. That means the denominator becomes the numerator, a plus b, all over ab. You can see that that's how to take the inverse of a fraction. Numerator and denominator switch their positions, equal to, and now the inverse of x is 1 all over x. Let's go ahead and separate the fraction on the left. Separating the fraction on the left, I have a all over, the denominator is ab, plus b all over, the denominator is ab. So this is equal to 1 all over x, as we can see there. Now notice that a here 1, a here also 1. So what is left? I have 1 all over b. So 1 all over b plus what I have here is b here 1, b here 1. So what is remaining becomes 1 all over a. So this is equal to 1 all over x. Well, I'm going to be writing the a before the b. That means I'm going to be switching the positions. So I have 1 all over a plus 1 all over b. It's still the same thing, equal to 1 all over x. So now let's write this back. We have 1 all over, what is our a? A is the square root of 9 plus the square root of 7 plus 1 all over b. What is b? B is the square root of 7 plus the square root of 5. So all these are equal to 1 all over x. Our next step will be for us to rationalize the denominators. Since this is short, we're going to be rationalizing the denominators. I'll rationalize the denominator of this. I'll also rationalize the denominator of this other one. Let's continue. So we're going to be using the conjugate to rationalize. So for this first one, I'll be having 1 all over the square root of 9 plus the square root of 7. So rationalizing with the conjugate is the square root of 9 minus the square root of 7. That's the conjugate of this, all over the square root of 9 minus the square root of 7. So this is for this, plus, let's do the same thing with this. We have 1 all over the square root of 7 plus the square root of 5. Now rationalizing with its conjugate is the square root of 7 minus the square root of 5. Remember, the conjugate is the different signs. So all over the square root of 7 minus the square root of 5. That's it. Equal to 1 all over x. Now 1 times square root of 9 minus the square root of 7 will give the same thing. The square root of 9 minus the square root of 7 all over. Now notice that what I have here is the same as what I have here. The only difference is the signs. So this is an expression of difference of two squared. That means it can be written as the square root of 9 squared minus the square root of 7 squared. So this is an expression of difference of two squares, plus, let's do the same thing here. 1 times this value here, I got the same thing. Square root of 7 minus the square root of 5 all over. Now the denominator is an expression of the difference of two squares. So square root of 7 squared minus the square root of 5 squared equal to 1 all over x. Now, having this, we have the square root of 9 minus the square root of 7 all over. Now, notice that the square can cancel off the square root. The same thing happens here. Now, leaving behind 9 minus 7. So, 9 minus 7 is 2 plus, let's do the same thing here. The square here cancels off the square root. Square cancels off the square root. I have 7 minus 5, which is also 2. So, square root of 7 minus the square root of 5 all over 2. So, all these are equal to 1 all over x. So, let's continue. So, let's combine the fraction on the left. So, combining fraction on the left, you notice they have the same denominator. So, that will be our LCM, 2. And since they have the same denominator, I can go ahead and add directly. So I have the square root of 9 minus the square root of 7 plus the square root of 7 minus the square root of 5. That's it. Equal to 1 all over x. Now notice that minus square root of 7 plus square root of 7 is gone. So that I have the square root of 9 minus the square root of 5 all over 2. Equal to 1 all over x. And since I am looking for x, I can go ahead and take the inverse of both sides again. Now remember, like I said, when taking the inverse of a fraction, it means the denominator and the numerator switch position. So let's do that. So this becomes 2 all over the square root of 9 minus the square root of 5. So that's the inverse of the left hand side. Equal to the inverse of 1 over x is x. You see that? Cool. Well, I can't leave my answer like this. I still need to rationalize. So let's rationalize using the conjugates. I have 2 all over the square root of 9 minus the square root of 5. So rationalizing with the conjugate of the square root of 9 minus the square root of 5 is the square root of 9 plus the square root of 5. Remember, I have to change the sign. So all over the square root of 9 plus the square root of 5. So that's it. So this is equal to x. So 2 times this expression is 2 times the square root of 9 plus the square root of 5. And now the denominator is an expression of difference of two squares, which is the square root of 9 squared minus the square root of 5 squared. So this is equal to x. And now solving this, we're going to be having 2 times the square root of 9 minus, okay, that's plus the square root of 5 all over. Now square here can cancel off this square, leaving behind 9. So square here can cancel off this square, leaving behind 5. So 9 minus 5, I'm going to be having 4. So this is equal to x, which is what we're looking for. So 2 here 1, 2 here is what? 2. Now let's go ahead and simplify this. The square root of 9 is 3 plus the square root of 5 all over 2. And this is our final answer. Now feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.